Okay, so let's recall that a relation R, a subobject R of A times B, is single valued when we have that if x comma y is in the relation and x comma y dash is in the relation, then that implies y equals y dash. All right then. So we have the same kind of setup as before. We write h to denote P1 after R and K to denote P2 after R. And we have this theorem 16.6, which says that R is single valued. If R is single valued, then H equals P1R is monic. Okay. So let's see the proof of this. So firstly, we have that this formula is always true, that chi r h of w comma k of w always holds. Okay, so let's see this. So what's the interpretation of this formula? Well, the interpretation of it is chi p1r comma p2r, which we can rewrite as chi r p1 p2r, which is chi r of r, which is always true. So there we are. Now, secondly, suppose that we have an object T and a pair of arrows C and C dash from T to R. So then if S is a variable of type T, then C of S is a term of type R. And we can use the substitution lemma. We can substitute W here, which has type R. We can substitute W for C of S. And we still get something that's true. So from that, we get that chi r of H of CS comma K of CS is true. And in a similar way, we get chi r of H C dash S comma K C dash S is true. Now, putting those together, we get that chi r of H of C of S and K of C of S and chi r of H of C dash of S and K of C dash of S is true. Now, what we're going to do is suppose that HC equals HC dash. So we're going to suppose H of C equals H of C dash. And we want to show that H is epic. Sorry, we want to show that H is monic, I should say. So we want to conclude that C equals C dash. So firstly, since HC is HC dash, we can use one of the equality axioms. We can substitute this C dash of S for a C of S over here, and we still get a formula that's true. But now this is in the correct form for us to apply our notion of single valuedness. So suppose R is single valued. Well, then we have that this kind of expression always holds. That when we have chi-r of x comma y and chi-r of x comma y dash, then we have y equals y dash. And if you look at this, this has exactly this kind of form. So we could take this and do the substitutions and then use this. And so if we set x is equal to HCS and y is equal to k of CS and y dash is equal to k of c dash s, then this gives us that KCS equals KC dash S. And now if we interpret that, we get that KC equals KC dash. So let's just see how we interpret that. So this is the expression we're interpreting. So the interpretation of this term here is here, and it is delta B after KC comma KC dash equals true, which means that KC equals KC dash. But then we've also assumed that HC equals HC dash. So we have RC equals HC comma KC equals HC dash comma equals HC dash comma KC dash, which is equal to RC dash. And since R is monic, we get C equals C dash, which is what we wanted.